If you're not currently a student in the Master's in Data Science program, we'd like to welcome you. Also, it's been a busy week here for data science at USF. We've had the launch of the Center for Applied Data Ethics on Monday, and we had the Schmidt Family Foundation here doing talks on the environment, data science in the environment. And now we're going to launch our seminar series with a talk from Sundar from Google. Before we get started, I just want to say a couple quick things. So first, we've got some events coming up. We've got our SQL and deep learning certificate courses. Those are going to be starting in early September, so check out our website for that. And there's lots of talks and events happening through the Data Institute with the Center for Data Ethics, so check out our website and look at the meetup for all sorts of good stuff happening there. Okay, last announcement. If you are visiting and are interested, one of the really exciting parts of our master's program is the practicum. So we deploy teams of students to companies where they work. Instead of doing a master's thesis, they work on a data science problem at a company for 9 months. So if that's something that sounds interesting and you'd like to have some students come and work on an interesting project with you, by all means, we'd love to talk. And so you can reach out to either myself or our practicum director. So that's Nick Ross in the back here. And we'd be happy to touch base on that. All right, great. So let's get started with the main event. So like we said, it's a great pleasure to welcome Sundar here. He is the lead data scientist and manager at Google Analytics. And he's got a background in statistics from Virginia Tech. So let's welcome Sundar and get started on our seminar.
Oh, what it is. Okay, can you guys hear me? Okay, good. So I apologize if you thought you were going to come see Sundar Pichai, who is the CEO of Google, but he is actively working in Mountain View, so you're stuck with me for the next couple hours. So as introduced, my name is Sundar, Dorai-Raj, and I've been at Google for a little over 10 years as a data scientist, although the data scientist term is relatively new. I think we only started calling ourselves data scientists about 3 or 4 years ago. Prior to that, we used to be called quantitative analysts, and prior to that, we were something like decision engineering support. There's like 4 or 5 names all strung together. So we finally conformed to an external industry pressure to start calling ourselves data scientists. We're still primarily embedded with engineering teams and product teams, but I'm going to go over a little bit today about what a data scientist is also, and how this sort of interacts with the other our counterparts on the qualitative side. So we're called quantitative analysts, whereas we have counterparts which we call qualitative researchers. So this was a great project that we worked on. It's actually almost 2 years old now, but we just started publicizing it more externally. It sort of blends this quantitative and qualitative research into a single analysis in a single product. Feel free to ask questions throughout. You don't need to wait until the end. Just raise your hand, and hopefully I'll be able to see you. If I don't, just call out. Oops. Okay, hopefully it doesn't do that too often. Okay, so this is the title of the slide is From Data Points to Data Diane, and we'll actually go through who Diane is at the very end, but there is a reason why there's a data Diane as part of this, and what these little characters you'll see throughout. These are all part of the presentation. Like I said, it was done about 2 years ago, but this whole project took well over a year to do, which is, at Google, it's not unusual for data analysis or data science work to be multi-quarter projects. In fact, those are the ones we like. The ones that we really engage with are the ones that are very open-ended, that take a long time to complete, and are very difficult problems to solve. So, no, it's not working. There. Okay. So before we get too deep into the actual analysis, let's just go over a little bit about what we mean by quantitative and versus qualitative. So at Google, quantitative analyst is typically what we call a data scientist. They actually mean the same thing. They're generally statisticians, as I was introduced. I have a PhD in statistics. Most of the folks I work with also are trained statisticians, either PhD or master's level. We do have quite a few math and engineering fields, but I would say at least half is statistics, and then maybe a quarter is operations research, which is very similar to statistics. Then we have a long tail of other backgrounds and other educations. But primarily when you think of quantitative analyst or a data scientist at Google, you do think about statistical modeling, machine learning, and all of these things that require understanding some of these more complicated models. We are also pretty adept coders, mostly Python and R. I was just having a conversation right before this about the people using Python versus people using R. Data science at Google is still heavily on the R side, but we see that sort of slipping over time, that Python is sort of making more of more inroads, especially as students like you are coming out of these programs where all you're learning is Python. We're actually going to see more Python users in data science over time. There's still some reasons why we use R versus Python. The statistical modeling part is just one aspect of it. The visualization part is also another aspect of it. But Python is certainly catching up. And the reason that Python is making more of an inroads is because you're starting to speak the same language as the engineers you're working with. I know when I'm at Google and I send some R code to an engineer, it's like poison to them. They don't want to touch it. They don't understand it. It's not really a real programming language that they were taught. So R is definitely still around, but I do see in like 5 or maybe even 10 years, Python being like the #1 language for data scientists. We also use Go and SQL and a few other languages, but generally these top 4 are the first ones we see. Qualitative research is more about user experience, understanding how users use our product. And the best way to figure out whether or not a user is using the product as you designed it is to actually ask them. It's harder to do through logs analysis. It's harder to actually figure out what a user is doing just by looking at their clicks and their hovers or whatever interactions they have. So generally, you might think of qualitative research, they do a lot more surveys, they do a lot more interviews directly with our users, and they focus entirely on what the user experience is in a more qualitative way. We, on the other hand, as quantitative analysts or data scientists, we focus on what the user is doing from the clicks and the quantitative approach. So both of them together, the qualitative side and the quantitative side, they both have their strengths and their weaknesses. With the qualitative side, they usually have very small sample sizes. They have, even a survey, when you're talking about a product like Google Analytics, which has got tens of millions of users, trying to understand what every user is doing, you cannot go out and talk to all 10 million users. So they send a survey and they get like a 2% response rate on that survey. They end up with about 1,000 responses. You can't really take those 1,000 responses and extrapolate it to 10 million users. Whereas with quantitative side, we actually do see every single thing the user does. And so we're able to join those two to get a better picture. But one by itself is actually hard to understand what a user is doing. So what is Google Analytics? Raise your hand if you actually have heard of Google Analytics before. Generally everybody. It's a pretty well-known product, but it's also a product that's mostly used by businesses. It's not used by individuals. We have a lot of individuals that use it. In fact, I was interviewing somebody a few months ago, and she said that she used it to track people to her dissertation website. just to see how many people were reading her site. It's mostly out of curiosity. She wasn't going to do anything with the data, but she wanted to see when she posted her dissertation online how many people actually went and looked at it. And those are the people that, I mean, it's free. Generally, it's just one little line of JavaScript that you copy to the top of your website, and then the rest Google Analytics does for you. There's not much effort into putting into creating a Google Analytics tag. This is a screenshot of what it looks like now. We're actually changing a lot of this over the next year or so. But as you can see things like how many users you have right now. This is a demo account, so it's a pretty small website. It gets a little bit of revenue and gets people from all over the world, although you can see it's mostly in the US or mostly in North America. And so this is the type of information we typically get or we provide to our users. And so when we talk about users are a little bit tricky with Google Analytics because they're not the same type of user as Google or YouTube. YouTube and Google users are very different from the users that we're talking about here. YouTube users, where they're more consumers, or Google's users are more consumers of our product. These people are more, they're companies. They're not really people. They're organizations that are using it. So you have, say, REI.com, who has a Google Analytics account. They want to see how many people that come to their website or come to a specific page on their website or come from a specific ad campaign. It's the organization looking at this. So as many people within the organization that are looking at this data, not usually just a single individual. And so when we talk about users, analytics, we actually talk about a collection of people, collection of people being a business. It is primarily, I sort of mentioned that analytics is, I sort of alluded to using it to understand ad campaigns. It is really a product for advertisers. In fact, organizationally within Google, analytics is part of the ads organization. And it's been like that for almost, I don't know, 6 or 7 years, I think. At one time it was its own thing, but then they realigned it to say this is really, it's mostly advertisers using it to optimize their campaigns. So who are our customers? Well, they're very diverse. I mentioned the university student that tracked traffic to her campaign or her dissertation, but it's mostly, like I said, mostly a product used by advertisers. Some of the biggest advertisers at Google rely on the data that we provide to make their campaigns better and make their website better as well. But it's got, just like the rest of Google, you have the biggest companies using it, but you have this very, very long tail of small companies using it. And we're mostly focused on the people who actually advertise with us, so the hobbyists. They don't have an ad campaign. Most of our work is actually to help the people who are spending money with us. But they're also people. They're not just companies. And so we have to sort of find this balance of what's right for the business that uses us and what's right for the user that's actually part of that business. We do see a lot of churn at Google Analytics. A lot of people who came last week or last month don't come this month. And a lot of the reason is natural attrition within a company. People leave, or people get promoted or demoted, or they just move from different job functions. So we want to make sure that these experiences are consistent across those boundaries as well. So the focus of this project is to actually understand who these people are and who these customers are. In that way, we could actually make the product better. We don't know, we kind of know the businesses that use these, but we don't know how they use them. And so we spent a year gathering as much information through surveys and analysis to actually come up with a better picture of who is actually using our product. So that's the focus of this talk, is this blending of quantitative and qualitative research, and how we could actually understand who is using our product and how we can actually develop the product to be better with time for these specific users. So this is the general flow of what we did. We started with logs data. There's 2 parallel paths, the top part being the quantitative the quantitative analysis part, and the bottom part being the qualitative, and then we blended that into a single clusters, and then we ended up with 9 personas. And we'll go through some of the definitions of what we have up here throughout the talk. So let's start with logs data. As you're probably all aware, you guys have all been on the internet for a couple of decades now, probably. We do track a lot of what you do on the internet. It's very anonymized. We never look at it in single user form. We always do it in aggregate. But everything, just about everything you do on the internet is that you click on or interact with is logged somewhere for people like me, data scientists at Google or any other internet company, to analyze and understand patterns that are in those clicks. So at Analytics, we collect just about everything that you click on. This is just a screenshot. If you open up the Chrome developer tools, I don't know if you ever play with the Chrome developer tools, and you click on anything on the internet, it'll spew out like dozens and dozens of lines of code that are being generated from every single click. You think one click is just maybe one line in the logs. It's generally dozens and dozens of requests to our servers. And so we track a lot of this. We store a lot of this information. Some of it we don't store. Some of it's not very interesting. But some of it we do store, and eventually we're able to analyze at a later date. And so we're going to collect all of this data. This is called what we call logs data, and try to find patterns within that logs data. So the way we do this is we typically organize a user's information into what we call sessions. And sessions are essentially a smaller unit that we can analyze. There's a general rule on how a session is defined at Google. It's pretty arbitrary. It's just a heuristic that says there's a certain amount of time gap between one click and the next, then it's a session. And so in this example, we're talking about which one is this? Oh, this one. We have some user, just a generic user. We know who the user is. In Google Analytics, it's 100% login. You have to be logged in to use it. So we know who this user is. We take all of what they do in analytics. They look at some report. Maybe they're looking at their ads report. Maybe they're looking at their country report. Maybe they're looking at their conversion report. They're doing that in one session. They come back later. They do a few other report views, and then they come back later. They maybe do one report view, and then they come back later and they do a couple other report views. So we organize the data into smaller units such as sessions, so that they're easier to analyze. It's not just one big clump of data. We're able to break up that clump of data into smaller pieces and actually do our analysis. But before I get into that, this is still very messy to look at. There's so many different reports on GA or on analytics. There's hundreds of reports that people can look at. So it's hard to find patterns in this. And a lot of the times, there's only like for a particular user, they might only look at a handful of reports. And trying to compare that to a user who sees tons of reports, it's hard to make a comparison between the two. So it's very messy data. I've organized it in a way that looks very nice and easy to deal with, but this is very, very messy data because of all of the ways that people can actually view these reports. So how do we do this? Because this is a very messy data set, plus it's very sparse. There's a lot of reports that only get viewed by a handful of people, but they're sort of embedded with these other reports. This sparsity creates problems with understanding what people's intent on the website is. So what we do is we actually cluster the reports. We actually use something called LDA. LDA stands for Latent Dirichlet Allocation. It's similar to a bag of words type of algorithm, but it allows us to take these very sparse reports and cluster them together as they occur because of their co-occurrences. And so essentially LDA on top of the sessions data is a way of reducing the dimensionality of that data. The data has got a lot of single report views. There's a lot of people messing around with the date ranges that also get incorporated into this. Or is that really important? So because there's so much noise, because there's so much sparsity, we actually have to do some sort of dimension reduction before we could actually start clustering the users. So LDA is a great algorithm to actually to do this, this type of analysis. So this is just a very simple representation of LDA. The Wikipedia page is probably, if you want more detail on LDA, we're not going to go over LDA today. It's a little bit more complex than just this one slide, of course. But you can think of it as you want to take each one of those sessions and come up with some sort of probability that there was an intent for that session. What was the use case for that session? So we have to, there's literally an infinite, well, not infinite, but there's millions and millions of use cases that you can think of. But that's too many to think of. So we want to narrow it down to just a handful of use cases. And LDA is a way of taking that sparse data and sort of and creating these probabilities that there's a specific use case associated with it. So how does LDA work? Going back to my session view, I have my sessions, I have my session 1, my session 2. But notice that session 1 and session 2, they're subtly different. I have a report D in session 2 that's not part of session 1. Are they really different sessions? And what LDA does is just gives you a probability that it belongs to a particular use case. And so in this case, I'm saying that the highest probability that it's use case 1 is for session 1. And for session 2, the highest probability is still use case 1. There are other use cases that session 2 could fall into, but this is the one with the highest probability, so I'm going to label it as use case 1. Same thing for use case 2. So even though I have 4 very different looking sessions, I'm only getting 2 use cases out of it. So I no longer have 4 sessions, I have 2 use cases, which are much easier to deal with. I'm reducing the dimensionality from 4 to 2 in this example, which makes it easier for us to work with rather than trying to deal with each individual report. So from there, now we could actually do clustering. So we first take this highly sparse data and we reduce the dimensionality of it from tens of millions of use cases down to, I'll give it away, but it's 25 use cases. And now every session that we have a label that says this session is use case 1, this session is use case 2, and so forth. And then we can find all the users that go through each one of these use cases and cluster them based on the use cases that they exhibit in the logs. So we came up with 25 distinct use cases. Unfortunately, I'm not able to tell you what these use cases are. As you'll see in the next slide, they're just use case 1 through 25. But you'll see some patterns in there which I think are kind of interesting. But the clustering we use is simply just a k-means clustering. Well, simple. If you've never used it, it may not be simple. But it's a simple algorithm. It's not overly complex. But we still have to choose a number of distinct clusters, and we ended up with 12 clusters. Yeah.
Yeah. So I just wanted to make sure. So the first time you were kind of clustering basically patterns in the logs, and here you're clustering
the users.
users.
Yeah. So just to reiterate what Yannette said, I'm first clustering the use cases in the logs, and then I'm clustering the users based on those use cases. So there's two steps here that we're trying to accomplish. Is that what you're? Yeah. Okay. Okay. So this is what it looks like. We have 25 use cases on the y-axis, and then we have 12 clusters on the x-axis. And so what we noticed immediately is that and actually these clusters are ordered by the number of users in them. Question?
So you use the k-means, but you will be the person to determine how many clusters.
Yeah.
So why don't you compare with like maybe hierarchical clustering or other kind of clustering?
We did go through, just to restate the question, she asked if we tried other clustering. We did try other clustering techniques. K-means was just the one that we ended up with. They didn't give fundamentally different answers. But we did try different. In fact, LDA wasn't the first thing we tried either. What you're seeing here is like the last thing we tried on all of these. Yeah.
Is there a rationale for k-means versus
There's no real rationale, no. It kind of depends on some of the characteristics of your data set. But in this case, it wasn't, there was no single characteristic that said we should use k-means or hierarchical. They didn't give fundamentally different answers, and we just stuck with k-means.
Yeah. And also for 12, are you thinking about the granularity? Because I feel like 12 is really hard to differentiate between the clusters.
Yeah, but we actually end up, we do see very, very strong differentiation. And that's why we ended up with 12. 13 or 14 didn't give us more information that we could have gotten here. So yeah, we did see a lot of differentiation, but that's exactly what we look at is if we add 13, how much do they really change? And they didn't really, like the 13th one was just noise. It seemed like very noise. Yeah. Is there another question? I thought I said it. Okay. So yeah, these are all great questions that, like, how do we choose 12? 12 seems arbitrary. I mean, 25, at least it's divisible by 5. That's usually a sign that, like, it's not so arbitrary. But both of them, the 25 took some visual inspection to say, well, 26 doesn't really make much sense, or 20 doesn't make much sense because there's not enough differentiation in the users on one side or the other. 12 is the same thing. If we added more clusters, we end up getting more noisy clusters at the end. These are all, these clusters are sorted by the number of users in them. So if you add 13, these clusters get smaller and smaller and smaller until you're actually getting fewer and fewer people in the clusters. And so what we see here is there's some interesting things. If you notice that for cluster 1 and cluster 2, they essentially only do one thing. They do either this use case or this use case. And I'll give it away what this use case is. They're just coming in, they're literally only checking one report. How many visitors do I have to my website? That's it. That's a very, that's why we're calling this a very novice cluster. They're not doing much with the site. They're just coming, they're looking, and then they're going away. They're not doing anything more sophisticated. I actually can't remember what this one is. I think it might be like where people are coming from, like referrals or something like that. But they're only doing it once, and they're leaving. So these patterns came out very clearly that these are and also it makes sense that these are the biggest clusters. The biggest clusters are the ones that don't know how to use our site very well. The more interesting ones are actually over here, where we have a lot more use cases within the cluster. We were calling cluster 12 the super user, because they essentially do everything. And they do just about every use case. Some of these top use cases, nobody does, so it doesn't matter that they don't use this, but almost nobody uses this use case anyway. So all these different blocks have some sort of direct meaning to our website. But some of them are unclear. Like if you look at, I think it was cluster 9 or maybe 10, I'll actually talk about it in a couple of slides. It's unclear what this user is doing. They're doing a lot of stuff, but they're not doing everything. So in order to actually figure out what they're doing, like these were easy because there were just one use case and they were pretty simple. They were going to call them novices, and that's it. But some of these are more complex. So in order to actually understand what they're doing, the only way to do that is to ask them, is to actually say, what are you doing? What are you doing on our site? And so that was the next step. This is where the qualitative side comes in. So the parallel path of qualitative research. We did all of this. It's not, and I say it's parallel. It's not entirely parallel because we did use some of these early surveys to actually inform some of the clusters later on, but it wasn't completely independent. But we did have to go back and actually figure out what these users were doing. So we used the survey data to actually interpret some of the clusters. So these surveys are fairly straightforward. They're not really invasive. They just ask basic demographics. They ask what your job role is, what the company that you're working for is, the size of your company, the industry, the revenue buckets. We don't actually ask them how much revenue they have, but we ask them, does your company make more than $1 million or more than $10 million or something like that. Very granular stuff. But if you've ever dealt with surveys, you know they're horribly biased. I mean, and there's nothing you can do about the bias because the people who respond are selecting themselves into your survey. It's not like a poll where they randomly select people and they get people to answer. We send out 10 million emails to different individuals. We might get maybe 1,000, maybe 2,000 back. So the number of people that get back is a very small sample size compared to the number of people we queried. But the information is still useful because the information hopefully gets us some sort of representative sample. Even though we're not worried too much about the individual users, it might give us more information about some of the use case or some of the jobs or people have that are using our site. So I think our first survey had around 1,500, maybe around 2,000 respondents. And with these surveys, and this is all clear in the survey, your email is recorded with the survey response. And so we're able to actually take those surveys and join it back with our logs data. Because the logs data has email in it, we can do a simple join between, oops, I went too far. We can do a simple join between what we see in the clusters. All the clusters are logs data. We know which users from our survey are in each one of the clusters. And so we can find that cluster that I said was confusing and look at their survey results to see what they were doing or what their job family was or what companies they were working for. Small sample sizes, we all know it's very small sample sizes, but at least gives us a little bit more color about some of these clicks that are not clearly interpretable. So that came to a very nice result in that we found that just about everybody that answered the survey in this column worked for an agency or consultants. So they went around and they did various things, but they were doing it for different companies. They were like the way agencies work is they have they have their own set of clients, and so these folks are handling different client requests. So that's why there's a lot more diversity in this particular column because they were handling different use cases. The people were the same, but the use cases changed depending on the client. There's no way we would have ever figured this out just by looking at this and studying it for hours on end. We have to talk to people. And so that came to our last component of this. We have these interpretations of the clusters, but we want to actually turn these clusters into more concrete things that we can wrap our heads around when we start talking about designing a new product. And this is where our second round of interviews came in. And what we did was we actually went through all the clusters and randomly selected people from each cluster, except for the novice clusters. We actually did not survey anybody or interview anybody in the novice cluster, mostly because they actually don't come back. So even trying to capture somebody in the novice cluster was difficult because they came, they looked at their report, they literally never came back. So how do you contact somebody who's finally left the site and has no interest in coming back? So we focused on more of the complex clusters. So in product design, a persona is an imagery, yet realistic, imaginary yet realistic and detailed description of a group of actual users. So we talk about personas, we're not actually talking about people anymore. We're talking about these traits that sort of describe how people use our site. So they could be a collection of traits across people, and not just single people. So we use these clusters along with the second round of interviews to design new personas for GA, for analytics. And so we came up with 9 personas. These personas are based on these user segments. All of the avatars, all of the names were created in accordance with what we think that person is doing. They're all little monsters. They're all very, very cute. We have these hanging all over our building in Mountain View. And they have all these personas have very different people or different traits associated with them. They also don't map directly to a cluster. So we have 12 clusters and 9 personas. The personas actually could map to several clusters. It's not an even one-to-one, but it's a way of saying that you might, depending on who you are, you might actually fall into multiple clusters. It's actually not uncommon to see that people fall into multiple clusters. The way k-means works, the way clustering works is that people are mutually exclusive within a cluster. If you fall into cluster 1, you cannot fall into cluster 2. The way personas work are you can actually you as an individual can fall into several clusters depending on what you're doing at the time. So some major insights. Data Diane, that's the name of this talk. Data Diane was one that we found very interesting. They both came, and Helpful Hans, they both came from the same cluster, the super user cluster. But they had very different use cases. They had different, even though they looked the same in the logs, they're actually different people in general. Data Diane ended up being somebody who worked for a larger company, very senior. Helpful Hans was just the guy who worked in a small company. He just did anything anybody asked him to do. So they're very different in terms of the people that they represent, but they have very similar use cases. So this all sums back up. It comes all back to the logs data, the data that we actually measure, store and analyze, can only tell you so much about the person that's generating it. It's very difficult to get a complete picture of how people use our site or how people use our product without actually talking to them. And so we've been trying to do more and more of these studies where we look at logs data and we actually go out and talk to people to get an understanding of where the gaps are in our product. You know, we think as designers or as data scientists that we know how people should use our site. But as soon as that site is out in the wild, you're going to find something that you never thought of. There's just too many people to use the site in the same way. Somebody's going to use it in a way you did not expect. So to wrap it up, these segments, these personas, they've provided a really good story of how to build the next version of GA, which is what we're currently doing. We're building this next version of GA, but we're trying to build sections of it based on who we think is using GA. And these personas and these clusters are driving that production, that design. So they're mostly used by our UX designers and our front-end engineers to understand who they're building the product for and how that person will end up using the product. But they're also used to help understand which segments should we care about. Like the novice segment, one of the big projects that came out of this was we had a problem with novices. How do we get people more engaged with the site to show them that there's some sort of value to the site? There are some people who will always be a novice. They never wanted, like the PhD student looking at her traffic to her website. She's never going to become like the super user. But there are people that they get frustrated and they leave. How can we actually make sure that they don't get frustrated? And we have a lot of efforts around trying to make this site less frustrating. One of the problems that GA had is that it grew and grew and grew for 10 years without really thinking about how people are using it. People would add feature here, feature there, add this intense feature creep. And so we're now really rethinking which features are important to keep some of these users happy. Yeah?
Could you differentiate between those novice users who just came and left because they didn't have any use, and between those who were frustrated and didn't know how to use the features?
That's a good question. She asked, can we differentiate the novice users who just came and left without doing anything or the ones that were frustrated? Is that correct? No, we can't. So this is where talking to people makes a big difference. The problem with novice users is they're hard to reach because they've already gone. And so reaching back out to them is a pretty hard thing to do. There have been efforts on getting more people to survey, but it's usually talking to a big company and seeing if there are people within that company that use GA maybe once or twice. But sending a random email to somebody who used your site once, the chances of them replying are pretty much nil. So it is hard. It's very hard, but we don't have a differentiation. But good question. So that wraps it up. I can take more questions now.
Sorry.
Go ahead.
I have a question. So you said this project was done 2 years ago?
Roughly, yeah.
Do you think the number of personas might evolve?
Oh yes, the number of personas could definitely evolve. So we tried to make these as complete as possible so that it wouldn't evolve as much. The clusters themselves most certainly would evolve as we add new features or we redesign part of the product. Especially now, we're going through this big redesign. In July, we just launched a new version of GA, which covers both web and app properties. We didn't really cover app very well before that. And so this will definitely not apply to the new users of our site. The personas we think will, because they're not really, they're sort of a blend of what we see in the logs versus these the job families people have. We don't think the jobs that people are doing are going to change fundamentally in a short period of time. Over time, yes. The clusters definitely will change from the old product to the new product because we don't even have feature parity across them. So doing task A in the old version may be different from doing task A in the new version. And the way it appears in the site might actually be very different. Yeah. Question? Yeah.
I was just curious about cluster 11. I was looking at the graph with the cluster use cases. It looked like that was one that was doing one thing a lot that no one else was doing.
Yeah, I think that's all admin. Yeah, all they're doing is adding and deleting users from their site. I think it was that one. It might have been this one. I can't remember. One of the two is just, yeah. They do one thing, but they're not really using the site. I can't remember which one it was, though. Yeah, good question. Yeah.
So the clusters are more towards the personas. They are the personas, right?
Mm-hmm.
But your customers are organizations.
Yep.
So how did you balance between finding out clusters depending on the personas? Was it because of the features that you had that you chose these clusters, or was it the result of the algorithm?
So how do we come up with the interpretation, you mean? Or how do we,
Yeah, I mean,
So a lot of it had to do with this demographic information. So knowing that you are doing, so for example, a novice user, well actually we didn't really do novice users, but somebody who's looking at a few different use cases, if they are part of a small business versus part of a very large business, that determined which persona they actually were. So it wasn't just the clusters themselves and not just the use cases, but that combined with all the other demographic information that allowed us to get an interpretation of the cluster.
so the sectors or the industries could be interpreted through the person.
Exactly, yeah. That's actually a better way to put it, is that we're interpreting the personas based on what company these users are coming from. Yeah, question?
Have you had in the past where the qualitative doesn't match with the quantitative, vice versa?
Yes, and it's frustrating. Somebody's wrong. And it's hard to figure out who it is. I mean, you kind of want to blame it on the low sample size of the qualitative research, but you can just as easily blame it on the log data, just not logging things correctly, or just not interpreting the logs data correctly. But yeah, matching when they match, like they did in this case, when they matched, it's perfect. Well, I wouldn't say perfect. We had a lot of issues with just interpretability. And even then, we're not entirely sure that we're interpreting things correctly because we're trying to take these surveys of, say, 11 or 1,500, 2,000 people and these interviews of around 40 people and coming up with an interpretation of 10 million users. That's a hard thing to defend in many cases, but they make intuitive sense. And if you looked at the first page, the co-authors I had were a mixture of data science and UX researchers in sales. We actually collaborated very heavily with sales because they're actually on the front lines of our product. They're the ones actually talking to customers every day. So working with them, we came up with a lot of the interpretations because they just have a greater amount of wisdom of who our users really are. But in the case where they don't match, it's hard to say what to do there. It has happened. I have seen it happen before where it just didn't make any sense. But you either blame one data source or you blame yourself for not interpreting things correctly. Yeah. Question? Yeah.
Sorry, I may miss the beginning part, but so you're talking about the response rate is pretty low.
Yeah.
So did you think about maybe putting like a small survey? They can choose to skip it, but the first time they're using the website?
Yeah, we have in-product surveys all the time, actually. You can't ask a lot of questions on them, though, because generally they will be dismissed at an even higher rate. These surveys that we're talking about, this one was several pages long. So you really can't ask that at the beginning. They are very annoying, so you kind of want to let them be a little bit more passive. If you're just pushing, like we have in-product surveys that basically, and you probably have seen these on other sites, where they might ask you, what are you here for today? You answer one thing, and then you submit, and you're done. But these surveys are too complex to get that much data. Yeah. Question?
So would it be accurate to say that a persona is a particular group of users that exhibit a group of behavior types? So if one persona can include multiple clusters, it's users who are a part of those clusters. So it's users who exhibit those 2 or 3 usage patterns?
Yes, yeah. So just to restate, because the personas don't map one-to-one with the clusters, we're saying that the people who fall into these personas could have exhibited different behavior on the site, depending on what they're doing that day, or depending on their overall job function. With the clustering, we're kind of getting snapshots of people. We're only getting what they did on this week or this day. With personas, it's more about their whole job, their overall job function.
Within the personas, is there any relevance, was there any interest in understanding how someone changes as a user during the first time they interact with the platform and the last time they interacted within that persona?
So not in a quantitative way. We didn't really look at how people transition from persona to persona, but we do know that people do transition from persona to persona. We did have, like, one of the personas, I'll have to remember which one it was, Startup Samir. They literally did everything on the site because it's one guy developing a web app, or developing an app, so he had to do everything. And so he was sort of a catch-all for, like, these guys were very focused on their work, on particular aspects of the site. This persona just did everything because they're literally a company of one. So very different personas. Yeah, question?
What kind of changes have been made to improve the user experience after this research?
Mostly it's front-end changes, how to make certain use cases easier to flow through. That's one of the things we really focused on. It also goes into designing the new version of GA that we just launched to try to make sure that these use cases are covered in an easier way, that the use cases are covered. And then we don't do as much quantitative research anymore, but we have continuing qualitative research around these personas where we continually talk to people. We don't talk to the same people over time, but we continually talk to the people within each one of these personas. The people have to self-identify into which persona they are. So we sort of we ask them what their job is, and we sort of say, oh, you look like a helpful Hans, and then try to understand how they use the site. But it's all, or show them like the new version of the site, and try to get feedback on what their use cases are and how easy it is for them to use it.
Do you have any specific priority for each persona?
Not really, no. A lot of the focus, I mean, like I said at the beginning, a lot of our focus is on the advertising side in general. So virtually everybody here is going to be have some sort of advertising. Like there's that cuts across all the personas. They're all advertisers. Yeah. Question?
So you're managing people, and I wonder if you could tell the students what type of work are they doing, more or less what's their, say, 1 day a week or a week look like for some of these people that you're working with?
Yeah, so you asked about like my broader team. So I manage 7 data scientists, 6 data scientists, I can't remember. I had one just leave and one just start, so it's kind of plus or minus 1. And they have varying backgrounds. Most, like I said at the beginning, mostly statisticians. One of the more interesting things that one of my folks is working on, it's all part of GA, by the way. Like, they don't work on any other product. They all work on GA or some aspect of GA. But one product aspect of GA, which I find to be super fascinating, is our experiment framework that we have. It's an external experiment framework called Optimize. There is if you know anything about A/B testing on the web, there's actually another company called Optimizely with the LY. That's not what we are. We are Optimized without the LY. But we have bigger market share than they do, last time I heard. They're actually, Optimizely is even former Googlers that left 5 or 6 years ago to create this product. But Optimize is an external A/B testing framework. So if you're a website developer and you want to understand whether or not, and this is a very simple example, it's not what actually people do, but say you think that changing the color of the submit button for buying something from blue to red will actually increase the number of times people click on it. That maybe that's your hypothesis, that people will actually click on it more if it's blue and not red. And so we have a nice Chrome app where you can go in and select the component that you want to change it to blue, and then say this is my variant and my control is going to be the red button, and we will divert the traffic evenly between the two, or you can say let's only use 10% of my traffic and we'll divert it 5% and 5%, and then we can track all the clicks on that button to see if there's a statistically significant increase in the number of clicks on that blue button, and show you this over time, that you're getting more clicks over time. So Optimize is a great little product to test out new features on your website. The more complex ways that Optimize are used is through personalization. So you can have some people have a personalized experience through Optimize, whereas you have maybe a non-personalized experience through the control. And then again, understand like how much money you're making through the variant, how many times people are clicking. The data science component of that, it sounds like it's all experimentation, but it's really not. The data science component of that is the model that goes into understanding that statistical significance. And all those models that we use to determine whether or not variant A was better than the control is we use Bayesian methodology. We actually use Bayesian models to give this estimate, so that when an optimized user comes to check on their experiment, we can say there's an 80% probability that variant A is better than variant B. And if you understand anything about the difference between Bayesian and frequentist, you can't say the same thing in the frequentist domain. You can say that in the Bayesian domain, that there's an 80% probability, you can treat it as a probability. Whereas in the frequentist domain, it's harder to interpret that way. And so people can make better decisions and earlier decisions based on this probability, and decide to launch and not have to worry as much about things like false alarms or the power of the test. That's all built into the models. So Optimize, I have one guy working on it, and that's 100% of his job. He is a pure Bayesian, hard-line Bayesian. If you ever meet a Bayesian, they're typically, that's all they will ever do. They will never do anything that's non-Bayesian. And but he's great, and he's really good at developing these new models. So he uses a package called Stan. Has anybody heard of Stan? It's a Bayesian language. It's a language for creating for estimating Bayesian models. Other folks on my team, we work heavily with revenue data to understand how much money flows through GA. One of the things that we have to defend about GA, so GA is primarily a free website. Most of the people that use it are free, even big companies that use it for free, and even the companies that do pay for it, it's minimal. I think it's like 100,000, maybe 150,000 a year for a company that makes $100 million a year. That's nothing to them. So where do we actually get our money? We're not keeping the lights on from people spending $100,000 a year on us, like a handful of companies spending $100,000 a year on us. So that's why we focus on advertisers. Advertisers spend a lot of money at Google, and we actually, as GA, see a lot of that money that flows through GA. So we do these studies to understand how much money does Google make after people adopt GA. And it's a whole field of study called causal impact. It's a very interesting, I kind of don't like the name because causal impact does not imply causality in any way. It's highly correlational, but what we do is we understand what an advertiser does before they adopt GA, what their spend is. We see them adopt on this single day, and then we see what their spend is afterwards. And we do this through a time series forecast and try to forecast the delta between what we forecast and what we actually see is this impact we get from adopting GA. So GA, we do a lot of these studies to sort of understand what GA's role is in the ads world. We are a free product, but we are an essential free product for many, many advertisers. That's a lot. So a lot of problems that we work on are heavily associated with how much revenue we make. And even more narrowly than that, how much revenue a particular product makes. Like Optimize has very few users, but they actually still generate a lot of revenue indirectly. It's all indirect revenue. None of it's direct revenue. Well, some of it is, but a very small portion of it is direct revenue. Other projects are around, like we work with a lot of machine learning problems, one with predicting conversions on apps, one with predicting for spam classification. Believe it or not, GA gets a ton of spam, as you might, some of you, if you've ever been on the internet, there's a lot of spam out there. We have, because we're a measurement service, we want to make sure that the data that people see, the advertisers, the publishers see, is not overrun by spam. We're not over-counting things. So we're working on models to actually predict spam and able to classify it much more quickly. Right now, a lot of the spam classification on GA is done heuristically. They have these rules and filters in place. But we're building these large-scale machine learning models using TensorFlow to actually predict spam. That's just a highlight. I can probably spend a full hour talking about all the different projects that we work on. My role as a manager is to oversee a lot of these projects. I was telling Annette before, I haven't really done analysis in probably like a year. I sometimes get a little itchy for it, but I do still get my hands wet every once in a while. But it's simpler stuff now. Like I have more people working for me. I delegate a lot more and direct a lot more, but not actually type as much anymore, which is unfortunate.
All right, let's thank Sundar again.
Yeah, and thank you for everybody. If you need to reach me for anything, you can contact Annette or you can Google me. I mean, I'm all over the net. Thanks.